Well, the motorised camera project is coming on nicely. I've now got a nice DC motor implementation running. So the setup is basically the same. We've still got the sensor in there. And basically how the system works is I'm using a rising interrupt, an Arduino code. And basically all that's happening is I'm measuring the time as the shutter's spinning. I'm measuring the time between that point, the leading edge of that shutter blade there, and the leading edge of this shutter blade. So what happens is the Arduino measures the time between those 2 points, compares that with a time that I've set inside the microcontroller. I'm sure it was 40 milliseconds, and it adjusts the motor speed accordingly to try and maintain that speed. So basically what I've created is a sort of crude PID controller. So I'll show you it working. It doesn't respond fast to load. If the load increases slowly, it stays in sync reasonably well. But if I'm to increase the load quickly, it takes a little while. So I'll increase and reduce the load slowly and show you how it performs. So as you can see, it's sort of in sync with the camera's frame rate, 25 frames per second. So I'll slowly increase the load. Now I'll take it off again. Now I'll change the load really quickly. So as you can see, it does not respond quickly. I'm not really sure how to program that in for it to respond quickly. Also, the reason why it's not staying exactly at the set speed is because of the Arduino's digital to analog converter. It's only 8-bit, so you only get 256 possible values from 0 to fully on. So the only way around that would be to redesign the whole controller using this, which is called a blue pill or an STM32, and this has a much more accurate digital to analog converter on it, so this would probably be a better option, but I'm not totally sure how to port the code over to that. It may be possible I will have massive complications with the LCD screen working along with the interrupts and the motor and everything like that, but the only way I'll know is just to set this up on a breadboard and just give it a try. But that's where we're up to on the project. This is just an Arduino Pro Mini. It works reasonably well. I'll put the code as it stands on this video. I'll upload the code in the description, and you should hopefully be able to have a look at it there. And it's just a MOSFET in the controller now. There's no stepper motor controller anymore, and it barely even heats up. So this system is better than the stepper motor. It starts up instantly, it never seizes, and it's much more reliable. I've certainly not burnt out any MOSFETs with it.